All right, so let's implement selection sort. Now, as I said, when I implemented bubble sort, I'm not going to create the projects on screen anymore, so I've created a new project. I'm putting the code into package academy.learnprogramming.selection-sort. I've added our array, I've added the code to print the array, and I've added the swap method that I wrote in the bubble sort video. So if you didn't watch that video or you need a review of what this method is doing, you can go back and watch that video. So let's get cracking on selection sort. So we're going to say for int last unsorted index equals, and once again this will be intarray.length minus 1, because at the beginning of the implementation the entire array is unsorted. It's in the unsorted partition, and so the last unsorted index will be the last valid index in the array, which is 6. That's length minus 1, and we want to keep going as long as the last unsorted index is greater than 0. Once it hits 0, that means the entire array is sorted. And we're going to decrement this on each iteration. So this is starting out exactly the same way bubble sort started. So we're going to initialize our largest index to 0. So right now we're saying that in the unsorted partition, the largest element is at position 0, because we haven't actually looked at anything yet. And then we're going to say for int I equals 1, I is less than or equal to the last unsorted index, I plus plus. And what we want to do is we want to traverse the unsorted partition and look for the largest element. So we're going to start at 1 because we've initialized largest to 0. So we want to say, is the element at position 1 greater than the largest element that we know about so far? Because if it is, then we need to update largest. And we're going to do that until we hit the end of the unsorted partition. Now, unlike with bubble sort, we do need to check the element in the last position. In bubble sort, we didn't need the equals because we were comparing I against I plus 1. And so the last index we wanted to check was last unsorted index minus 1 against last unsorted index. But here we want to compare every element against whatever's largest, so we need to compare this last element as well. So that's what the equals is doing here. And so that's what we want to do. We want to say if int array I is greater than int array largest, because that's the largest element we know about so far, then we want to update largest to I. So we're going to compare 35 against 20. On this first iteration, 35 is bigger than 20, and so largest is going to get updated to 1, and then on the next iteration we're going to be comparing against 35 because that's the largest element we found so far. So once we drop out of this loop, what do we want to do? Well, we want to swap the largest element that we found with the last element in the unsorted partition, so with the element that's sitting at last unsorted index. And so we can use our handy swap method to do that. So we'll pass int array, and we'll pass largest and last unsorted index. And that's it. We have implemented selection sort. So if you, once again, if you're having trouble understanding this, review the last video where we go through this by hand with the slide. So the outer loop is the one that's increasing the sorted partition by 1. It's growing it from right to left. And the inner loop is the one that's looking for the largest element. And then once we've looked at all the elements and we know which one is the largest, at that point we're going to swap the largest element with the last element in the unsorted partition. And when we loop back around, of course, at that point we have grown the sorted partition by 1. And so we subtract 1 from the last unsorted index. So let's run this. Let's see if this actually works. And it does. Here's our sorted array: minus 22, minus 15, 1, 7, 20, 35, and 55. And I'll just close this off. Now, as I said, this is a quadratic algorithm, O to the n squared. And once again, we have 2 loops. And I said that that's a hint because usually each loop can be considered n. And so we have n times n, and that gives us O to the n squared. So that's selection sort. On each traversal of the array, it selects the largest value and it adds it into the sorted partition. I'll see you in the next video.